All right, let's do the checkup practice problems. Remember, these are going to prepare us directly for the APEX quiz on the 6.5.3 that's coming up. So a quick hint that we want to remember is that that negative coefficient flips the graph over. So a quick hint is a negative coefficient flips or reflects our graph. So what do I mean by that? I mean, if we had an original graph of y equals x squared, there's my parent graph. If I then made a negative x squared, a negative coefficient, it's the same exact graph reflected over the x-axis. A negative coefficient reflects the graph over the x-axis. Okay, so that's just a quick hint before we get started with this. We're going to be looking at stretches, compressions, and flips or reflections. So let's take a quick peek here. First one, if f of x equals x squared, what is g of x? So here's my normal parent graph. Here's my new stretched, flattened, whatever you want to call it. So g of x has been horizontally stretched or pulled apart by a factor of 5. So we're going to go ahead and show the calculation here of our new function. So g of x is going to be equal to 1/5 of its usual. So I'm going to write out the words now too. G of x has been horizontally stretched or pulled apart by a factor of 5. Notice that instead of it going back 1 up 1, it's now back 5 up 1. It's been 5 times the normal. It was normally back 1, it's back 5. It's been stretched or pulled apart by a factor of 5. And we look back at our examples of our notes from the study guide, and that shows us that when something has been stretched horizontally, we're going to be looking at a fraction inside the parentheses. We could also say it's been vertically compressed or pushed down by a factor of 25. But so starting so far, we're going to say horizontally stretched by a factor of 5 based on that negative 5,1 number that they're giving us there. Okay, let's go look at another one. F of x is equal to x squared. There's my normal parent graph. So what's g of x? This one is a skinnier graph. This one was wider, and this one's skinnier. So the words for this one are that g of x has been horizontally, what do you think? Compressed or pushed together this time. By a factor of 4. Okay, where did I get this factor of 4? How can we see this? So look at the original function. Look at where it normally went out and up. Notice that it's now at negative 1/16. It's got an interior change that's happening this time. So we would say that y, oh, sorry, I should probably call it g of x, not y. G of x, its real name, is equal to 4x squared. There's a horizontal compression, which puts that 4 inside with the input. You could also say that g of x is equal to 16x squared. It is 16 times, it is growing at a rate that is 16 times the normal stretch. Both of these equations would work. You need to be able to find the correct one on APEX. Okay, let's look at this next one. If f of x equals x squared and g of x equals 5x squared, then the graph of g of x is the graph that is vertically whatted by a factor of 5. And so if there's a 5 in front of the x squared, it's been vertically stretched by that factor of 5. How about this guy? If it's inside the parentheses with the input, then the graph of g of x is the graph of f of x that has been horizontally whatted? What do you think? Hopefully you said horizontally stretched by a factor of 5. So based on whether it's saying horizontally or vertically, you're going to look back at your study guide notes to look at those pictures and decide, even though there's a fraction in here, it's being stretched at a compression factor. Stretched at a factor of 5. Okay, let's try a couple more of these. Remember to pause the video, try them, and then see if you got it. That's really helpful. So if f of x equals x squared and g of x is equal to 7x squared, we can say that the graph is horizontally whatted. It's been stretched by a factor of, just kidding. It's been compressed by a factor of 7. Because it's inside the parentheses, it's a horizontal compression. So a 7 inside the parentheses is a horizontal compression. Okay, let's look at this last one. The function g of x is f of x equals x squared, has been vertically stretched by a factor of 2. It's been reflected and flipped over the x-axis. So we're going to say that g of x equals negative 2x squared, because we want the negative coefficient because it's been reflected and flipped over the x-axis, and because it has a vertical stretch of 2, we need that value in front of the x squared to be a 2. How'd you do? All right, number 7. Suppose that f of x equals x squared. Sketch the graph of negative f of 1/5 x to show the general shape and direction. So for this one, we know that it's going to be flipped because of the negative. It's flipped so that its orientation is going to be downwards. And if it normally goes over 1 and down 1, this one is going to go over 5 and down 1. Over 5 and down 1, because it's got a 1/5 inside there. So go ahead and show from 0, 0, it going out super wide for this sketch. It's upside down because of the negative, and it's 1/5 of the normal stretch from before. So what was normally out 1, down 1 is out 5, down 1. It's a 5 factor, but it's wider in this case. So suppose on this next one that f of x equals x squared, sketch the graph of 4 times the original function, showing the general shape and direction. Let's go take a look at that one. So for this one, our normal graph would start here at the origin, and it would normally go out 1, up 1. But this one wants 4 times the usual. So out 1, up 1, 2, 3, 4. Out 1, up 1, 2, 3, 4. It is a skinnier graph that is climbing 4 times as fast as the usual, as the parent. So here's our skinnier graph that's 4 times as fast. All right, last two, 9 and 10. Number 9 says the graph for g of x is shown, and it's got the x squared right here. Here's our parent graph in the dashed graph. It's been changed somewhat. Which of the following could be the equation? Notice it's been flipped, so the first thing I'm looking for is a negative in front. So it's definitely not C. The graph is flipped over the x-axis, has to be a negative coefficient. The graph is also shifted up by 2 units. Now, be careful here. Did you notice that that was 2? 2, 4, 6, 8, 10. Careful on the scaling. So it's been shifted up 2. which of these equations show a shift up 2 with that negative coefficient? Answer should have been A. How did you do? Last, let's do this one again. Pause the video before I give the answers and see how you did. If our normal graph was here, notice that this is not only flipped, but it's a wider graph. It's flipped, it's wider, and it's been shifted down. And so let's look. This is 2, 4, 6, 8, 10. So it's been shifted down 3. So which of these equations have a negative for the flip, so it can't be A, have a wider or fractional graph, and have the shift down 3? Which one do you think it is? I hope you got it. Because of that 1/2, that tells us it's the wider graph. How'd you do? Do you feel ready for the APEX quiz?